So, good afternoon, everybody. My name is Anton Aksola, and as said, I'm here to tell you a little bit about deploying a public cloud with OpenStack, and especially the networking component Neutron. So, a quick introduction. I'm from a company called Nebula. We are an ISP / hosting provider / IT service company based in Beijing. I work there as a network architect, but I've been heavily involved with OpenStack for almost 2 years now. And I also have a passion for software development. Here you can see some of our company figures. We have roughly 120 employees and offering ranging from cloud services to traditional IT services. So, but enough of that, let's get started. So, OpenStack. Can I have a show of hands who here has done any work with OpenStack or at least heard of it? Oh, quite a lot. Okay. But in a nutshell, so OpenStack is a collection of software projects for providing cloud services. And the most well-known projects, or the core projects, allow you to run a infrastructure as a service cloud. So compute, storage, networking, identity, and so on. There are also a bunch of other projects that offer different features like database as a service. Then there's GUI orchestration frameworks and telemetry and stuff like that. But this is a networking event, so I'm going to concentrate to the networking part. So OpenStack Neutron. So what is Neutron? It's a network orchestration framework for providing connectivity to OpenStack Cloud. In addition to basic connectivity, it also allows users to define custom topologies, and it also handles the addressing inside the OpenStack Cloud, so IP addresses, MAC addresses, and so on. Then there are a bunch of supporting services such as DHCP, DNS, firewalls, site-to-site VPNs, and so on. These are implemented with multiple plugins, and those plugins can have different drivers and services, and those can be either commercial or open source. So there's really many ways to deploy Neutron, but in any case, Neutron exposes this unified northbound API, so whatever the plugins you use, you get the same API for interaction with Neutron. So, but I'd like to give you some context. So let's go back 2 years when we started researching for an alternative cloud platform. Before this, we had some experience with commercial products, and we done also some basic virtualization with Zen and Hyper-V with pretty much a static network configuration. So we have a few goals in mind. So this new solution must be flexible. So users must be able to provision new resources on demand. So network segments, subnets, routers, etc. And it would also need to be a fault tolerant. So we wanted to deploy this new service to at least 2 distinct data centers for fault tolerance. And this was also going to be a multi-tenant cloud, so user separation must be built in. And then there's the scalability. The solution must support large amount of configuration, and also the overall performance must be at least as good as with our previous offering. So what we had back then and still have, we had 2 data centers with almost identical network gear. We had So 10G converts data center network with servers connected with link bundles to both sides. And between the data centers, we had an MPLS backbone. So we had the ability to do any transport over MPLS, VPLs, and L3 VPNs. So this was a pretty good base for building a public cloud. But then this wasn't a greenfield deployment, so we had some existing customers. And we used VLANs for customer separation. So there would be existing VLANs, and VLAN IDs would be data center significant, so there was overlapping. And then there's the provisioning stuff. All of our provisioning are done by human beings with assistive scripts, and there were no existing APIs we could leverage with this new solution. So let's see what Neutron would offer us. At least back in 2013, Neutron offered these 3 different operating modes. The most simple one is the flat model, where all compute instances or VMs join to a single external network. So there's no customer isolation whatsoever, and no advanced features. Then there's the VLAN model, where users can create custom topologies, and Neutron allocates the segmentation IDs or VLAN IDs from predefined ranges. And then there's the overlay model, which is basically the same as the VLAN model, but an overlay protocol or GRE or VXLAN is used to transport the customer traffic in hypervisors. But in any case, all of these modes are implemented as a classical L2 network segment. So this is like traditional approach compared to other commercial public clouds for example, from Amazon or Microsoft that have their own forwarding scheme as well. And in Neutron, L3 functions are handled by these dedicated L3 agents. So we would have to make a choice between VLAN and overlay model. Naturally, because the flat model wasn't good enough. So comparing those two VLANs, pretty straightforward with what we have done for ages, predictable performance, ability to join legacy servers to these new networks. But then on the other hand, we would have a limited amount of segments available, as we have and there would be a need to coordinate with existing allocations. Queuing would not be possible because we wanted to have true NAT level separation, so overlapping MAC addresses and so on. Of course, we could use PBD, but then again, there is really no support in hypervisors for pushing a PBD tag. So if we wanted to transport those VLANs between the data centers, we would have to map them to a unique VPLS instances, again, to achieve the MAC level separation. And again, PBD VPLS would be an option, but we didn't have supported in all of our routers. So, and even if PBD VPLS, the amount of configuration would be quite significant. And lastly, with VLANs, there's really a need to either pre-provision them in all of your data center network gear, or integrate your networking gear with the OpenStack platform. Then the overlay model, there we have much more segments available. In the VXLAN, the VNID field is 24 bits long compared to 802.1q or VLAN tag, which is 12 bits, so over 60 million segments in VXLAN. And only one segment required between the hypervisors to actually transport the customer traffic. And this overlay model would give us the true separation in MAC level. And it would be agnostic to the physical network topology. Then on the other hand, the performance would be unknown. The overhead with, for example, VXLAN is much more severe than with MPLS or TRE. I think because there is like VXLAN has this UDP header in addition to the quite large VXLAN header. And of course, the lack of visibility or joining the legacy servers wouldn't be possible at this time. And then there's the problem with bound traffic, so broadcast anonymity and multicast traffic, which I will discuss a little bit later. So still we went with the VXLAN because at the time it was really becoming an industry standard, and it would give us the most complete set of features. So currently we run VXLAN only between the software components. Now there is hardware switches available also that can do VXLAN in the VXLAN gateway. So that would be an interesting thing to consider. So we use Nebula's L3 VPNs to transport VXLAN traffic between the data centers. And the external access to internet and other networks is handled by these Neutron network nodes that basically route between the external networks and the cloud networks. So no bridging whatsoever. So here's an example topology from a user perspective. Users can create complex network topologies and virtual routers on demand. And those virtual routers are hosted by the Neutron network nodes. Users can create inter-data center networks for example, database clustering or anything like that. They need to access the external networks, and floating addresses can be allocated to these virtual routers, which then can do one-to-one connect to the desired VLAN. And they can also do source net or VMs that don't have any floating addresses, so they can do the basic updates and stuff like that. So how this is achieved, I'd like to talk about L2 forwarding in OpenStack. Neutron has this modular layer 2 plugin that defines these type mechanism drivers. The type drivers handle the type specific stuff like segmentation IDs. And the mechanism drivers handle the port provisioning and stuff like that. There are many options available, both open source and commercial. So open source would include Open vSwitch, Linux Bridge, and Open Daylight mechanism drivers and so on. And the commercial stuff from Cisco, Arista, Nuage, and there are others as well, are mainly for interacting with their proprietary network hardware appliances. But the good thing is that multiple drivers can be ordered at the same time, so you theoretically have some part of some hypervisors doing using one mechanism driver and one other. But in our case, we wanted a pure open source solution, so we chose the Open vSwitch as our driver. So Open vSwitch is a flexible switching solution for Linux that actually runs in userland but has some data path support in Linux kernel. And we also went with the L2 population driver, which we'll discuss next. So Open vSwitch plus L2 population. Open vSwitch supports this traffic steering with open flow rules. and this allows us to run this L2 population driver with the OBS. And L2 population achieves, with L2 population, as every single endpoint in the OpenStack cloud is known, then we can do this, then we can repopulate the OBS forwarding tables before, so that this would drastically lower the amount of unknown unicast traffic. This is quite important because by default, when you're using overlay protocols, the broadcast traffic becomes replicated unicast traffic in a head-end hypervisor egress. Well, this is not entirely true because with VXLAN there is this thing called broadcast communication and mapping to multicast groups, but it's not supported in OBS, and for some reason there seems to be a little traction with that. So let's look at the L2 forwarding example. So here we have 3 hypervisors and 1 networking node, and we are looking at the OBS in the networking node. So the Neutron Open vSwitch agent populates the forwarding table with these entries, and then there we can see some shortcut entries to these VMs. And they have a MAC address and the output interface. And the output interface in this case is the logical VXLAN tunnel. And the last entry is the BAM entry that has multiple output interfaces. But it only includes the hypervisors that have VMs in this particular network. So it's like a partial mesh, again, to minimize the amount of replicated traffic. But there still is source learning, so you might consider this as an optimization feature, not a new forwarding paradigm. But there is work in OpenStack too. There's actually a feature called ARP Responder that actually, where actually the ARP requests stay inside the hypervisor, and the hypervisor will respond to ARP requests. And I would assume that this is also possible with IPv6 network discovery. So next, I'd like to share some of our deployment challenges. So as a whole, OpenStack can be quite difficult to deploy and time-consuming, especially getting it stable in production environment. Most of our issues have been software issues, so lots of bug hunting. So good development and QA environments are really important. The one thing to know that by nature of OpenStack, all the components are very distributed. So there's really no single central management point. So you end up having lots of replicated configuration that needs to be just right. So this is why I wouldn't recommend doing any OpenStack deployment by hand. We use some automation framework such as Chef, Puppet, or Ansible. And then we have the challenges with VXLAN. VXLAN is still quite a new technology. It was first appeared in 2012. This is a nice protocol in the sense that it's specifically designed for data centers, and it provides this outer UDP header and some entropy in the source address, source port for efficient hashing in L2 bundles and ECMP. support in Linux has been available for quite some time, so you could consider it quite stable. But there are still problems, which are actually not the excellent problems, but general Ethernet problems in Linux. Because as we move to 10G mix in servers, we really got dependent on the hardware offload features. Because with standard Ethernet size, with 10G speeds, you end up having over 800 kilopackets per second flowing. So if we were to process every single Ethernet frame, we would quickly max out our CPUs just for interrupt handling. So this is why the features such as GSO and GRO help us to handle this by combining these small packets into the larger ones. But these features which are implemented in the NICs tend to usually work only when you have TCP directly next to the IP header. And with VXLAN, you actually have the outer UDP header, then you have the VXLAN header, then you have the inner Ethernet header, inner IP header, and then perhaps TCP. So with VXLAN, you need to look deeper into the packet, and this support in NICs is still quite rare. And besides that, you really need a quite recent Linux kernel to actually support it. So at least upstream version of 3.40. But these things tend to improve as more people start using VXLAN. But even with further acceleration, if you need the absolute performance, you're still stuck with VLANs, especially if you don't like to do some SR, IOD, virtual functions, and stuff like that. So, okay, now it's a quick word from the sponsor. We launched our public cloud offering based in OpenStack last year. The launch has been quite successful. We've had many customers and they tend to be very happy with the product. We were our first public cloud in Finland based in OpenStack. Our offering is we offer true multi-data center solutions, so you can deploy your VMs to distinct availability zones. We have compute instances ranging from 1 CPU to 16 CPU and block storage in SSD grade. Then we also have this object storage based in this software called Ceph, which is kind of like the Amazon S3 if you are familiar with that. And as you probably guessed, all these user-defined topologies are at your disposal. We also have the GUI orchestration framework and telemetry services available. But most importantly, all the standard OpenStack APIs are at your disposal. And we have few public references. For example, Rovio is using our cloud for their software development. And we also offer the MPLS VPN to their office, which is then connected to this cloud. So let's quickly look at some screenshots from the system. So this is the basic dashboard. It is the OpenStack Horizon dashboard with some modifications. There is the network topology view, where you can quickly see your virtual routers and compute instances. And then you have the option to also use the CLI tools, CLI clients, which you can use with any OpenStack cloud. So a really quick way to provision this stuff. So this has been my presentation. Thank you. Please visit our website for more information. And I also have a few colleagues here who can answer all your questions. I'll be here for the whole evening as well. So thank you.
Red, blue, or black?
Red is fine.
Red or blue?
Red.
Thank you.